All right, let's dive into something that sounds like it's straight out of science fiction. We're going to explore a wild scientific claim, and it's all about concrete, magnets, and whether the two have a secret connection. We're going to look at the actual lab research that put this idea to the test.
So let's just get right to the big question, the one that got my attention. Can you really make stronger buildings with a magnet? I mean, we're talking about concrete, the single most used building material on the entire planet. The idea that a simple magnet could improve it sounds, well, a little crazy. But that's exactly what we're going to investigate. Okay, so magnets and concrete. You don't usually hear those two words in the same sentence, right? It's not exactly an obvious combination, but some new research suggests there might be a powerful, and I mean powerful, connection here. Let's dig into what the claim is all about.
And here it is. This is the core claim. If you pass water through a magnetic field before you mix it into concrete, you can dramatically improve the final product. It's a pretty bold statement. So the question is, how on earth could that possibly work?
Well, the theory behind all this comes down to a concept that, honestly, sounds a little strange. It's the idea of making water wetter. Now, this isn't about just adding more water. That would be bad. It's about fundamentally changing a key physical property of the water itself.
To get our heads around this, we have to talk about something called surface tension. You've definitely seen this in action, right? It's why a drop of water holds that perfect little dome shape, or how some insects can literally walk on a pond's surface. It's the force that makes water molecules want to cling to each other. And when you're mixing concrete, that stickiness can actually prevent the water from mixing in as efficiently as it could.
So here's the fascinating part. The research suggests that by passing water through a magnetic field, you actually reduce its surface tension. The water molecules become, in a sense, less sticky and more fluid. This allows the water to get in there and more thoroughly coat every single tiny particle of cement and sand in the mix. And as you can imagine, a better coating leads to a better chemical reaction, and ultimately a much stronger bond. And this isn't just a hunch, they actually measured it. The researchers found the magnetic treatment knocked down the water's surface tension by 7.4 millinewtons per meter. Now, I know that sounds like a super tiny number, but in the world of molecular forces, that's a really significant shift, one that could have a huge ripple effect on the final concrete.
So the theory sounds pretty plausible, right? But how do you actually test something like this in a lab? Let's break down exactly how the researchers set up their experiment.
The way they actually magnetized the water was surprisingly simple. I mean, look at this. They took regular tap water, used a basic submersible pump to get it flowing, and then just circulated that water through some permanent magnets over and over again for 45 minutes. That's it. That was the entire secret ingredient. Okay, next up, they prepared the contenders. They made 6 different kinds of concrete to compare. As you can see, everything's in pairs. You have one with regular tap water, labeled TW, and its partner with magnetized water, or MW. They tested a standard mix with nothing extra. Then they added 2 common strengthening materials to see what would happen. SF is silica fume. It's a superfine powder that makes concrete denser. And FA is fly ash, which is a byproduct from coal plants that makes concrete flow better and get stronger over time. This setup is perfect for a direct head-to-head showdown. All right, the concrete is all mixed, poured into molds, and ready to go. Now comes the really important part, putting these samples through the ringer with a series of intense tests to see if there was any real, measurable difference in how they perform. They focused on 3 really critical measures of strength. First is compressive strength. That's basically how much force it takes to crush it. Then there's splitting tensile strength, which tests how well it resists being pulled apart. And finally, flexural strength, which measures how much it can bend before it breaks. Together, these 3 tests give you a really complete picture of how tough the concrete is. And they didn't just test it once. To see how the strength developed, they ran these tests after 7 days, then again after 14 days, and finally at 28 days, which is the industry standard for measuring concrete's full, final strength. So, after all that meticulous preparation and testing, what did they find? Did running water past a magnet actually do anything? Well, the results were, to put it mildly, pretty surprising. So, get this. Before the concrete even hardened, they noticed a huge improvement. The workability, which is just a fancy word for how easily the wet concrete flows and fills the space, was way better in the magnetized water mixes. We're talking 10 to 35% better. That's a huge deal on a construction site because it means you can fill complex forms without adding extra water, which always weakens the final concrete.
Now let's look at the hard numbers. This chart shows the compressive strength, the crushing resistance, for the mix that included fly ash after 28 days. See the bar on the left? That's the normal tap water mix. The one on the right is the magnetized water mix. It's not even close. The magnetic treatment gave it a major leg up. So how much stronger are we talking? In that best-performing mix with fly ash, the magnetized concrete was over 16% stronger. Let me tell you, in the world of construction materials, getting a 16% boost in strength from such a simple, cheap treatment is a massive improvement.
But believe it or not, the results were even more dramatic when they tested tensile strength. That's the ability to resist being pulled apart. Again, just look at the fly ash mix. The magnetized water sample is towering over the standard one. This is a huge deal because tensile strength has always been concrete's biggest weakness.
Check out this number, a more than a 28% increase in tensile strength. That is just staggering. It tells us that the magnetized water must have helped create a much tighter, more cohesive internal structure.
And the winning streak continued right through to the final test, flexural strength, or bending resistance. The pattern is crystal clear. The magnetized water mix with fly ash just blew its regular tap water counterpart out of the water.
So, what's the bottom line here? Let's recap the big takeaways. The study clearly showed that using magnetized water boosted overall strength by a huge margin, anywhere from 10 to over 28%. It made the concrete easier to work with, and really interestingly, the effect got even stronger when they added things like fly ash. The researchers basically called it a proven slam dunk technique for making better concrete. And this whole thing just leaves you with a fascinating final thought. We've been using concrete in one form or another for thousands of years. If something as ridiculously simple as a magnet can unlock this much hidden potential, it really makes you wonder, doesn't it? What other simple, game-changing secrets are just hiding in plain sight, waiting to improve our world?